Okay, before we get going into like the very first page, let's talk about functions. What do you guys think what a function is? I see if this is a normal class in person on the ground class, I would just ask you, and several of you will raise your hand and talk about it. But in the interest of time, this is what a function is. Okay, what am I talking about here? This red part, okay? So a function is kind of like a black box, okay? You can think of it as a black box or a magic box or a specific modules with a number of logics, okay, embedded in it. This logic is something that you write, right? And this black box or this, this red box right here takes a set of inputs, okay? A set of input is illustrated here, okay? So this input could be a number of like basically feedback from the external system, okay? So you can think of it, think of your program as a model for the entire sort of question space, problem space that you're trying to model against. So you create these functions to help you solve maybe a small portion of your program, right? To deliver the solution. So you can do this in divide and conquer way. But in any case, I'm just trying to define what a function is. Okay, so if what goes in represents the input, what do you think the output is going to be? It's going to be on the other side, right? So this is your output. Okay, now in programming, this input could be, something that you ask the users about. So you already did that in your homework 1 or 2, chapter 1 or 2, right? Asking the user to enter something. So what comes in through that input function is the kind of like the external feedback that goes into the function. Okay, so to the extent what this, this red box is doing, it's really this particular function's business. Okay, so as you can see, if I were to continue on, right, and having a whole bunch of these functions, so every single function is kind of represented by this, red box here, and they could be of any types and shape. It doesn't matter. I'm just using this as the illustrated purposes. So you can have a whole bunch of these things, and then of course for each of these functions, there's input, there's outputs, right? And it is very possible that this particular input kind of goes into this other function, right? This is function A, right? And then you have function B. So A kind of calls B, and then B calls, like its output becomes an input for C, or maybe the C calls B back, right? Well, in this case, this will be catastrophic because if it goes back to B, then you have this what we call infinite loop, right? So C calls B, B calls C, and then back, right? So typically you don't want to have something like this. Okay, so does it make sense? So at runtime means when you hit execute, right? Or run buttons, you can have a multitude of these functions encapsulated in their own sort of ecosystem, and every function has its own sort of scope, so to speak. So what happens inside a function stays inside a function, right? So that's sort of logic, that combinations of statements encapsulating in each of these A, B, and C becomes their own thing. Ideally, what you want to do is to make sure that first of all, the function has a name, right? You don't want to call it A, B, and C. You want to do something like get number of students, or get grade, or count number of keys, or something like that. Depends on what that function is doing. You want to name it appropriately. That's one thing. First, that's one thing. And two is each function has its specific purposes, right? This purpose could be, just get the number of grades you have, or to sum up, do a summation of all of the numbers that came in. As long as you don't want to make the function that is huge, a function could be unit size, meaning it is lean, it's not going to leave any what they call side effect or anything that would change the state of your program. Then it's considered a good function. But anyway, the overarching kind of the premise behind function is that one, it encapsulates a whole bunch of logic that you can't see from the outside, okay? But, and that's the first thing. The second thing is it takes input, okay? And then it outputs something. So this input could be a whole bunch of arguments coming in. or it could be 1, right? Whatever this is, right? It could be an array coming in, it could be another string coming in, or it could be 3 integers coming in. Doesn't matter. So when I say input, it's a collection of the external sort of feedback coming at you. Output, like I said, it could be anything, right? It could be an array or a list with a whole bunch of feedback or computed results, or it could be a single integer. It doesn't really matter. So I'm using these both input and output very literally, right? To represent what goes in to this black box, right? In this case, red box, right? Black box, red box. The same thing here. I can't do it in black because you will not be able to see the box against the black background here. You're gonna see a set of output that comes out of it, okay? So going in and coming out, okay? So in computer science, we also call it ingress and egress, right? All right, so that is function in the upshot, and let me just go through the specific mechanics associated with the function. So let's move on to the next page here. So what you see here is kind of like a stored steps. What does that mean? Well, this function has a couple of very interesting facilities. First of all is def. So this def stands as a short for definitions. So you have definition in some other languages, you call them functions. But in Python, you call it def, right? So definition. And then what comes in the definition is basically your logic. So your logic is pretty hello fun right here. Okay, and just notice that there is a semicolon, not semicolon, I just call it semicolon, colon here, okay? And then you need to have a proper indentations here, okay? So with these proper indentation, this entire 3 lines defines what a function is, okay? So whatever this thing is doing, right, this is what this thing is doing is, oh, no, I'm sorry. This entire definitions here is coupled with the execution of a whole bunch of other stuff, okay? And this whole bunch of other stuff, stuff number 1 is the invocation of this string. So you define this, and then because you're invoking this string, this thing is gonna, this thing is gonna be calling upon this definition to execute this line. And so, okay, I know this is kind of confusing right now, but let's just be mindful here. The spirit of this problem and this particular slide is to showcase the fact that you are defining function to make your code reusable, okay? What does that mean? Well, you can call upon this function, 2,000 times, and every time you call it, this function is always going to be faithfully executing instead of logic. This allows you to build reusable code, right? You can modularize, right, your code into sections where each section is responsible for doing its own thing. So you can kind of think of it this as, have you guys played Legos before? You guys don't know what a Lego? Okay, so you have Lego pieces, and you can use these pieces to put together a giant robot, right? You can think of each piece having its own function. So in order for you to construct the entire robots, you put these Lego pieces together one at a time. And some of these Lego pieces, like, the arm, right, or the leg of a robot consists of a whole bunch of other pieces together, right? These things could be repeated, and you can just repeatedly using the building block to build them up here. What does that illustrate? How does that relate it to this notion of reusability? Well, just think of it as Lego pieces. So you can put these things together, right, to make something. And certain pieces in a robot could be repeated, right? Like the shape of your arm and leg, right? Well, if there's no notion of left and right, let's say if this robot, every arms or extension looks the same, then you can make these things repeatable. So that's kind of like functions, right? You can write these things. You can encapsulate, as in you can aggregate, right, the same logic together and bundle them together for reuse later. Like in the case of calling thing twice here, right? First of all, you call this thing, and then you print something else, and then you call it again, right? So this is cool because then you don't have to say hello fun here. You don't have to do another hello fun. So this also saves the code. Reusability also connotes to the notion of making your code leaner, writing leaner code. Leaner code and reusable code is pretty much in direct relations with each other, right? So by having reusable code, making your code a lot more modular and composable, also shrinks the footprint of your code. So what does that mean? Well, if you have a smaller number of lines to compose your program, that program runs faster than another version that calls for 20% more code, right? So the leaner it is, right, the smaller your compiled unit, the less time it takes for your CPU to interpret it, which means that your code runs faster, okay? So this function, leaner code, reusable code, and it allows you to better maintain your code, okay? So these are some of the benefits of what we're using function to begin with. Does it all make sense? I hope this makes sense. This might be a little bit philosophical, but hopefully you guys will see the reason behind this. Okay, let's get into the Python functions here. There are two kinds of functions in Python. One of them is called the built-in function. So you have done a fair amount of it, I hope. One of them is called converting something into something, right? So integer takes strings, right? So you can convert whatever this object is into a string. You can also convert whatever this object is, right? When I say this object actually goes into the two parentheses here. And then you can also ascertain the type, right? Data type of this object using type and then parentheses and whatever that object is there. Okay, so on and so forth. This is what we call built-in functions. So these built-in functions in other programming languages or in computer science is what we call libraries or plugins or facilities. Anything that comes equipped with your native Python environment is what we consider in the context of this lecture built-in functions, okay? So these things are kind of free of charge. You don't have to pay for it. It's available for you to use. If you don't know what they are, you can consult python.org, that huge, the Python consortium website. There's APIs available or a number of the Python resources. I think I have listed out many of those resources online. You can go into these websites and to see the available built-in function. So this built-in function is also native, okay? So native, what does that mean by native? Any takers? Native means already available. As soon as you install Python on your machine, these things come with it. So you don't have to worry about importing or getting it or downloading it from somewhere else. As soon as Python runs, your code, you can use it. The good use of a online IDE helps that effect too, because go online, any Python IDE that supports version 3, for example, should have built-in function that supports Python 3 language syntax, right? Okay, so that's the first kind of function, and the other one is something that you write yourself. So this is the most exciting part. I don't want to use someone else's. I don't want to write them from scratch, right? So there's a fair amount of use of the function. This is called custom-defined function that you can write in Python. And this is the part that we're going to be focusing on, especially in your assignments too. How would you be able to create your own function and take it from there? Okay, so we treat the built-in functions name as new reserved keywords. We avoid them as a variable names. Yes, so just be careful. Every time you invoke as in you try to call it, okay? You try to call these built-in functions, you don't want to use the same thing as your variable name, right? That could be problematic. As a matter of fact, I don't know, yes, yeah, you don't, because when you call a function, sometimes you don't have to send it in parameters, and it looks like you are, you're calling a variable name, which is not good. So do not use these as like the built-in function names as some sort of, variables names that you want to create. So just be mindful of that, right? So avoid naming your variable input type, float, integers, and try to call them because you could be calling these things. All right. How would you know? Well, sometimes you'll know your IDEs, if smart enough, will alert you to the fact that you're misusing your building function names as something else. Okay. Any questions about this slide? All right, cool. Let's move on to the next one, which is function definition. Okay, so I want to be super clear about this. If we don't get this naming conventions correct, terminology, so to speak, then it's kind of very hard to communicate, right? Just remember, every time you're learning a new language, you have to know the basic keywords and right the vocabularies. Okay, so without this, then it's very hard to kind of build the grammar up, right? It's like in grade school when you guys learn what is a pronoun, right? Him, his, hers, theirs, right? Things like that. And if you don't know these things are actually called pronouns in English dictionary, then how would you be able to learn your grammar, right? So we gotta kind of have to do the same thing here with function definition. So definition is whatever you're defining it. And the signature of the function and the logic in the function has to all be there in order for you to define it, okay? If you don't do that and you simply just want to spell out what this function looks like from the shell level, it's what we call function declarations, okay? We're not declaring a function here, we're defining a function, meaning we're implementing the logic in there, okay? So in Python, a function is some reusable code that takes, okay, so we did that. Our arguments as input, there's some computation, and then returns a results. Okay, now there is actually a difference between arguments and parameters. Okay, so let me illustrate this. So let's go back to my black box or my red box functions. Okay, and this function takes, this thing, right? Input and output. Okay, so externally, right, as you looking at this function right now for the very first time, you can see a set of input going in, right? This input, whatever this is, right? It's also what we call arguments. Okay, so I'm going to be cautious because you can have maybe one argument going in, or you can have multiple of them. Okay, so this input is generically a collection of these arguments, whatever this is, one to many. Okay. Or it could be zero, because sometimes you don't have to have an argument going into the function to execute it. All right, so in this case, externally, what goes into the function is what we call arguments, okay? Now, when you do a function definition, you have to declare what this function looks like, and then you're gonna see these, what we call parameters, right, inside the function. Now, parameters and arguments are two different things. Okay, so I just wanted to make sure that we set a precedence on this thing, that you guys understand moving forward, what I meant by arguments and what I meant by parameters. So the good news is we're going to talk about parameters in a couple of slides. So just remember what argument is, okay? So argument is what goes into the function from the external world, okay? From the external world. Okay, so that is one thing, okay? So this is arguments coming from external world. So this is orange thing, okay? And the second thing is about this DEF reserved keyword. So when you see DEF, that's definition, okay? You're defining what this function is. If you're not done, so definition means that you have to have that colon and then whatever the logic that you have in there to conclude, right? Your entire function definition is there. So what you need to do. So number one is argument. Number two is def, right? And the third thing is that you can invoke the function by using the function name. Parentheses and arguments in an expression. Okay, so you guys remember what an expression is? Expression is typically combined with what we call a statement. And it's not combined, it's what's available inside the statement. And that statement has some sort of assignment to it, right? Expression is a combination of operands and operators. So this expression could be just invoking this function, okay, simply by itself. So this is basically this number 3 is how you can run your function. It's not really a part of function definition, so I kind of disagree with how whatever this author is doing for putting the very last bullets here. Okay. So now we know what is the most important, which is the definition part as well as the argument. Let's move on to the next page. Oh, any questions about this so far? Very straightforward, I hope. If not straightforward, make sure you just read up on the, there's a whole bunch of reading assignments for you, okay? All right, let me clear this and move on to the next one. All right, so there is a functions here, and this is basically the number 3 bullets that we were just looking at, the invocation, okay? The fact that you are calling a function. This function is in pink right now, okay? And this is the function, and this is actually the built-in function. What this is doing, if you read what's called API. API stands for Application Programming Languages. This is documentation for this API, for this particular function. This function looks at your collection of characters and find the largest one, right? So the largest one typically means the specific word, specific character that has the largest, the ASCII, right? So ASCII is spelled ASCII, okay? So you guys know what this is. This is the international standard for describing what a character is in computer science from its basically your feedback. So if you go to, okay, let me see if I can share this other screen. Okay, I'm gonna type in ASCII table, right? So ASCII table is something like this. You can go into any of these ASCII tables and you can see that every single one of these. So basically the very first 250 characters, 128 characters are basically everything you see on your keyboards. Every character is like A, letter B, C, D, 1, 2, 3, 4, 5, even exclamation, tilde, carrots, and everything like that has a number representation. This number representation in the ASCII table. So ASCII stands for American Standard Code for Information Exchange. Okay, and then if you look at these in the table, you'll see something like this. And this table is not well represented. Maybe let me just go back here. Sometimes you can go to image and then you can select any tables here, and then you can kind of click into it. I'm not going to click into it, but you can see letter A has a hexadecimal representation of 41. Decimal has 65, right? And the lowercase w has letter 111, 119 right here. Okay, so what is my point? Now, if you go back to what we're talking about, min and max. So min and max is a built-in function that essentially computes the biggest number in terms of its ASCII representation in this entire collection of characters. So W actually comes out to be the max, right? And if you do a min, and you just look for maybe the very first word, I don't know what this is, right? Maybe, I think it's probably D, whatever this is. So this is min and max are both built-in function that you can call. And notice that in order to invoke your function, you have to invoke its what we call function signature. And this is not described here. Function signature is in Python, right? Function name, parentheses, parameter, okay? And this could be a number of parameters here. And that's how you invoke a function, right? If you look at this, the function name is max. Parentheses is what's in pink here, and the parameters S, right? Or 0 to many, it's hello world right here, okay? And the reason why I call it parameters here is because this function signature is how you define your function as. So whatever you have in this function as you define it are really just the 1 to many 0 to many parameters here. And the argument is what user passed in. So in this case, the user passed in what's called hello world. So this becomes an argument. Okay, does that make sense? Okay, and then this is what we call the expression, right? The entire thing, even though there is no plus sign, minus sign, you're simply invoking a function. This entire thing is what we call expression, EXP. This is not exponential. Let me just expression. Okay, guys, bear with me because I don't I'm using my mouse here, so I am so fortunate that I can even write this. This is what we call expression. Expression assignment, right? Equal sign, equal this big. So this big, by virtue of what is on the right side of this entire statement, this entire thing is called, we'll call statement. But if you break them down, the equal sign is assignment. What's on the right side is what we call expression, which turns out to be a function invocation. And the result is a character, is a string. And this string is stored inside this variable called big, okay? Does it all make sense to you? Any questions about this so far? I'm kind of just going through the kind of the overall landscape of how you invoke your functions, right? All right, so as soon as you get your big, which is the variable containing the largest ASCII characters, you print it. Same thing with your min, and you try to print the this tiny. It turns out the minimum of this is, remember, every single character, including even this space right here. I believe space is 38. Okay, don't quote me on this, but it's one of those ASCII numbers, and it turns out that the space is the one that gets printed. Okay, so it's not D, right? It's space. Anyway, you don't really have to memorize this ASCII, hierarchy here, but just remember, okay, that every single character on your keyboard represents a number that has a decimal number associated with it. Okay, any questions about this? All right, cool. If not, let's go on to the next one, erasing this. So this max function, okay, I think I did most of the work here already. This argument that goes in, hello world, is what we call, well, I already told you the argument. And what this function returns is a string, okay? So string in Python is represented either with a single quote, in this case, single quote W, right? Or a double quote. So you can literally have a double quote W. It's the same as a single quote W. So this behavior is the same as in JavaScript, okay? But it's not the same in C++ though, because that one is more complicated. Not going to talk about it. So a function is some stored code. So this is what I call encapsulated logic that we use. A function takes some inputs and produces an output. Is exactly kind of the premise behind the construction of a function and what it is, right? Make sense? Okay, so Guido wrote this code. I have no idea what this means. This is probably it's probably the author of the next one, okay, so Guido wrote this code. Okay, so this code, max, is something like this. Okay, so what happens in the original function definition or declarations here, has a def and has a function name, and this definition also has a parameter called IMP, right? So whatever this is, this IMP in this case, from the argument standpoint, is called hello world. Okay, fine. This IMP, hello world, is going to be blah, blah, blah. Blah, blah means etc. Anything can happen. For x equals, so this is how you write a loop. For every single character inside this string, you do blah, blah, blah. So there's some sort of blah, blah, blah comparisons, right? Blah, blah, blah stands for etc. So Guido wrote this code. Everything is all encapsulated in this navy blue, right? Or baby blue box right here. And so as to the function logic that you need to implement is anything you have in this. Okay, lots of times people make some mistakes in their logical expressions implementation. So you got to be super careful with that. Okay, any questions about this max function? Okay, so we're not going to talk about min. Min is pretty much the same but in reverse, right, of max. So let's talk about type conversion. So if you recall from our 2 lectures ago, we were talking about converting something into a flow. We were talking about ascertaining what the type of this data type is, data variable is, and then we also talked about converting it to integer, so on and so forth. So when you put an integer and floating point in an expression like this, so expressions, remember whatever is on the right left side in this case, if you simply just have this entire statement with nothing, like no equal signs, it's also an expression. So expression is something to be evaluated. Okay, so you can think of it that way. So typing type parentheses I is something to be evaluated, and that would evaluate this to a class integer, telling you that I is actually an integer. Okay, so if you have an in or floating point conversion, the integer is converted into a float. So this allows you to convert an integer, right, 99, to a float, which is 99.0. So 99.0 divided by 100. This basically means floating has an 8 bytes and integer has a 4 bytes, right? What does that mean? Well, basically that means this entire type that gets converted from integer to float now, it's gonna have 8 bytes of memory space. This means 4 bytes of those is gonna be the standard 99, right? And then the other 4 bytes, which is kind of extra additional padding, you're gonna see a whole bunch of zeros. So when you have so the point of I'm trying to make is when you have a much larger data type divided by a smaller data type, what computer is doing, okay, internally, your CPU is converting, right, these smaller data type into a much bigger one as well, so that it fits the division operations here. Division operation says 8 bytes divided by 8 bytes, right? You cannot do 8 bytes divided by 4 because you're gonna run into some sort of truncation and stuff like that. Your your Python interpreter is not gonna let it happen. So your Python interpreter in that case is gonna convert the entire float divided by integer, right? This is a float divided by integer, basically giving you a float, right? And then that's kind of how this goes. And the other way around, by converting a float into an integer also stands. This means that you lose what's called precisions. It's a whole bunch of float decimals will be converted into zeros. Why? Because when you do a float to integer, you're shortening the amount of data that you have by truncating a lot of those, decimal ones, keeping just the integer ones. So you're gonna lose scientific precisions for doing that. So there is what we call upscale, upcasting, and the other one is downcasting. So from float, from an integer into a float is what we call upcasting, right? You're upping, making it bigger, and downcasting means that you're truncating stuff. Okay, that is besides the point. This kind of explains the reason why by converting just one of the integer into a float, and the result is actually a float, 0.99. Okay, so I just explained it. What else? So why are we talking about this type conversions here? I guess the spirit of why we're talking about is because this is part of the building functions. Float is building function, so is print, right? Print is a building function. Building as in someone else implemented for you already, and these functions come equipped with your Python IDE runtime or CLI. So is type, so is float. These things are all input or building functions that are native with your Python environment. Okay, so any questions about type conversion? It's 8:03. Let me just go on for another 10 minutes or so, and I will take a break, okay? Sounds good? All right, the next one up is what we call string conversion. Okay, so just to remember, string conversion is what we call string manipulation. Every time you're dealing with string converts takes up probably 80%, if not more, of basically areas of computer science. Everywhere you go, okay, any computing problems that you're solving involves string, inevitably string. So you have this string called 1, 2, and 3, and remember, string is encapsulated with either a single quote or double quote. So in this case, we use single quote. Single quote sval stands for string value, right? And if you were to convert, just invoke a type on this string val, you're gonna get class str. So what is a class? So let me just go over this. This is very curious. Okay, so have you ever seen a brand new house construction right across the street from you, or maybe next block to you? Okay, so you see these new houses being built, right? You can't really build anything without an architect drawing up some sort of blueprints, right? So blueprint is kind of like a two-dimensional piece of paper that has a whole bunch of specs, right, on this, telling you what this house is going to look like. And then the architect or construction crew comes in and look at this blueprint and build a three-dimensional house for you, okay? So what am I talking about here? Well, you can think of a class, okay, as a blueprint to something that you can build, okay? And this SVAL right here is what we call object or an instance or a block of memory that occupies that has some values at runtime, right? So this SVAL is kind of a 3D house you're building right now, and it's being built by virtue of having SVAL equals 1, 2, 3. Because what does that mean? That means 24 bytes of memory space has been allocated, and that allocated 24 byte has a label, and that label is SVAL, okay? And the value that is sitting inside that 3D, right, memory space is 1, 2, 3, right? So you have this 3D object, and that 3D object is of type class str. So this class is a template. It's what we call class declaration. This class declaration str type is going to be a constructed 3D dimensional SVAL with a value 1, 2, 3 at runtime. Does that make sense? So this is the reason why when you do type, you see class something, right? So this is a class integer, and then class float, or some custom user-defined class. So you can actually, when we get to, excuse me, let me get some water. Yeah, sometimes I talk too much and I need some water here. And sometimes you want to define your own class, your 3D kind of your own template, okay, your own blueprint to instantiate something, to build an object at runtime. So we'll talk about that later. The point of this is that you can use integer float to convert between string and integers. Just so you know, if you have a string and you use in on it, this converts that string into an integer. And obviously, what you don't want to do is to have SVAL be a non-numeric integer. So this requirement for doing in on a SVAL requires this SVAL to be what we call numeric string, okay? So this has to be a numeric string instance. So instance means it occupies some sort of memory. So at runtime, SVAL occupies some memory, 24 bytes. Okay, so when you do a type on it, you will see class integer because the result val stands for integer val. It's going to give you something that's integral, right? Okay, so when you print something and you get 1, 2, 4, that's fine. NSV, hello Bob. This is another a string, and this variance has hello Bob, which is not numeric, and you try to convert this into an integer. Of course, you're going to get what's called an exception. And this exception is not caught because you don't have a try except, and guess what? You get this traceback. And this traceback is a no-no because it stops your code from running at runtime, okay? All right, so this is an error that is irreversible. And when this happens, your code stops. Your execution stops. Your entire program basically exits, and then you're done. You have to rerun it again, okay? So this is what we call string comparison, conversions. Any questions about string conversion at this point? So we talked about string conversion. The next one is function of our own. Okay, so this is the pretty exciting one because now we get to define our own functions, right? I don't want to use any building function. Let's define our own. So building our own functions involves a couple of things. One is that we create a new function using the def keyword. Okay, so this check, we got this, right? So check right here. We create a function name of our choice. You usually, so there are two ways to create these functions. Two different best practices, so to speak. One of them is to use this is what they call underscore, right? So you can use this facility to do that. And sometimes people write them up simply as using camel case. So print lyrics. So if you look at this, the difference between print lyrics and the other one is print underscore lyric is that one of them uses underscore. So if you have like 3 words put together, you can have underscore in it. You don't want to put any spaces in it because that would simply be invalid. The first option here involves what we call camel casing, okay? So camel casing, so what is camel? Camel, you know, like, is an animal, right? It lives in the desert, and then it's got this hump on the back, right? So you see this hump that goes up and down. So it's kind of similar to having this lowercase and uppercase thing. So all of a sudden, when you have to abridge the spaces by eliminating it and making this entire collection of words into a function, you can use camel casing. So camel casing allows you to write uppercase and lowercase in combination of it. Usually the very first letter is lowercase, but everything else that separates that is space delimited, those characters you use the uppercase for it. So print lyric would have looked something like this. So that's one way of writing functions, okay, like this. And the other one is what we call snake casing. Snake casing, you can kind of think of it as a snake. You're concatenating these words together. So these are 2 different styles. And right now, I have to say print lyric like this in snake casing is more popular than using the camel casing. So snake casing is very clear, okay? Okay, so now you define your def. You define the name of the functions. And then you indent the body of your functions, in this case, namely all of your logics in these 2 statements. And then you do not execute the body of the function. So what does that mean? Well, you don't want to call it self, right? So there's nothing about print lyrics here in these 2 lines. So this is line number 1, line number 2, and line number 3. And 2 and 3 do not call itself, okay? So this 1, 2, 3 itself, it's a self standalone custom or user-defined function that you just did. And notice that there is a colon here, okay? So every time you write a function, just remember like your control structures where you have this if, elif, and then else with a colon, you have to have that with the function as well. So always remember this colon that is attached, this def in the name of the function is basically what we call your function signature. Line 1 is your function signature, basically saying, what does this function look like? This function looks like, well, first of all, this one has def, right, def. So this definition is a function. So this is a function line. And this function looks like it's got a name called print underscore lyrics. And then it's got its input as void. So this is what we meant by void, not passing anything. So there's nothing. So this function takes void function parameter list with nothing in it. Okay, all right. So any questions about building our own function in terms of what this function anonymy looks like? All right, cool. Let's move on to the next one. Well, the good news is we don't really have a lot of slides here. Okay, so you have your print lyric that prints these 2 lines. And so this is the code that we're writing here. First of all, we are declaring, right, a variable. This variable is named x, and this variable turns out to be integer because it's assigning to an integer 5. So this x is an int, okay? And then you print hello, and then you declare, right, like we did before. And then we print yo, right? And then we do x equals x plus 2, okay, fine, which means x is not 7. And then you print x. So what's going on here? Well, this is going to be printed, right? This one is not going to be printed. There's nothing printing it here because we're not calling this function. So from a runtime Python interpretation standpoint, interpreter will evaluate line, whatever this line is, and then this line, and then this line, and basically just do a pass through, right? Because there is nothing that needs to be invoked. Just simply just a definition. So you can totally at runtime have a collection of lines of statements that needs to be evaluated in value, and also a function that is kind of embedded in it. So what the good news about this is, even though this is not evaluated because no one is calling it, right? This function actually, what happens at runtime is it gets loaded in memory, okay? So loading of a function requires the amount of space as well. And that is a different topic on its own because yeah, in computer science, in computer, there's a set amount of memory, and this amount of memory that you have here in this red box here is what we call stack, and the rest of it is called heap. Okay, so this is kind of out of scope of topic for this, but since I'm talking about it, this function, this 3 lines of code actually sits inside your little stack right here. Okay, in this little stack right here. Okay. So what does that mean? Well, the evaluation of these 3 lines of function actually takes up some memory space. Okay, that is fine and dandy because you're simply just printing stuff to the console, right? You'll see hello gets printed, and then what's the next one? Next one is yo, right? And then the next one is 7, which is x. Okay, so far so good. This is what happens when you print this entire thing, right? The function gets loaded in the memory, it's not being used, fine, and nothing is printed, but everything else is printed. Okay, so that is kind of the upshot of calling this thing. Let's move on to the next one, which is definitions and uses. So once we define a function, so like we did, right, with the previous print underscore lyric, we can call or invoke. Just remember, we don't usually call it invoke. We usually, yes, in English, when we have to translate what we do in functions, we say we call the function or invoke the function. Either one is fine. As many times as we like, and this is a store and reuse pattern. Okay, I bet that. So function is a building block that you're going to be calling repeatedly, right? You can call it 10,000 times, and the logic is going to repeat 10,000 times. That is a good use of a function. So we talked about that before. Any questions about definition and uses? All right, let's move on to the next one, which is, okay, so now what's kind of different between this version and the version that we showed before is now we actually call or invoke it, right? So remember the definition happens here. And remember Python interpreter interpret lines of codes from top to bottom, right? Line 1, 2, 3, 4, 5, 6, 7. Okay, so at this point, okay, this would have been loaded in memory. Okay, this is what I'm going to do, write it loaded. Lock and load it in memory, and the specific memory is what we call stack. Okay, this entire thing is loaded in memory. So this is the reason why you can kind of call it, you can invoke it later on, because guess what? This print lyric has already been loaded in memory. So what does that mean by loaded in memory? That means this function has a pointer pointing to the specific address that stores this set of instructions in it. So this print lyric represents a pointer pointing to the specific locations in memory. So when you do print underscore lyrics, it goes into that specific memory 0 times FA2, something like that, and pull out whatever is in that bucket. And it's in that bucket, it says I am a lumberjack and I'm okay. I sleep all night, then I work all day. So these things get printed because you know exactly where they're located in memory, right? So in addition to hello, in addition to yo, you're printing this one because you're invoking the functions right on the spot right there in its execution path, right? Execution from top to bottom. You're printing everything out one at a time. Okay, so any questions about this? So I just want to make sure that you know, the concept it's pretty straightforward here and clear. All right. This one, excuse me. Okay, so arguments. And notice that we were talking about arguments using plural. An argument is a value that we pass into a function. So what is we? We is a user, okay? You as someone who executes this code. You're not a developer. So this is what we mean by we, right? Anybody who makes use of this function or makes, so sometimes when you have a collection of these functions, you call them libraries, okay? It doesn't matter. You import a library to call a function. Argument is something that we pass into a function. When we make use of this function, we pass in what we call arguments, right? Okay, so we use arguments so we can call directly function do different kinds of work when we call it at different times? Sure, because it depends on the argument you pass in there. So for an argument called hello world, this max function is going to return W, right? Because we talked about this before. Now, if we call this again with a different thing, maybe we don't have hello world, we have hello, then what's going to be printed, it's, I'm pretty sure it's going to be 0, O, right? So whatever this one is, this O is going to be a string. We put the arguments in the parentheses after the name of the function. And just remember though, the parentheses is necessary, right? If you don't have parentheses, then this max is simply just a variable. But because now you have parentheses, this signifies that you're calling what we call a function, okay? There's actually a difference between, you probably have heard maybe in some other programming books or online that people call a function method, right? So what is the difference between function and method? Okay, so you can think of this, right? So function is kind of like a standalone thing. Everybody sees it, it's global. Method is always a part of a class, okay? Just remember when we talked about class as a blueprint, right? So if there's a method inside that class, if there's a function that is embedded inside that class, then we call that function a method, okay? So this is kind of the difference between the two, but then again, it's semantic at this point because you haven't gone to class. You don't know what it is yet. So I'm just saying, introducing these variables, so, you know, so argument, functions, and parentheses, and the difference between built-in versus custom design, defined function, and function signature. So these are the kind of terminologies that we use so far, right? Any questions about this? All right, as you can see, we are close, maybe halfway. Okay, so parameters. Now parameters is a little different because we talked about parameter as what you define inside this, right? So this is not what we call arguments, because when you define a function, you have to specify what goes into that function. And that specification, right, when you define your function, is called parameter. And this parameter is usually a list of things. So it's not just one parameters. It's not just one param, but parameters as in multiple. There's plural of them. It is a handle that allows the code in the function to access the arguments for a particular function invocation. True, because in this case, what is en? En is argument. So what is es? Es is an argument. So fr is also an argument. But lang, L-A-N-G, as you recall, Python does not have any type, right, associated with it. So whatever that type of that variable is, in this case, a parameter, is what gets passed in, right? So you can say that this lane is of class star. So if you do a type lane, you're going to see class str, okay? Str, which signifies string. So this en, es, frank, these are language notations here. There are string. So this is argument, okay? This is also an argument. So this is also an argument. Argument. Lane is what we call parameters. Okay. In this case, there's only one parameter, so I'm just going to use a singular parameters or param. Okay. Yeah, let's take a look at what this greet is. So it's basically doing a what we call string-to-string comparisons. This lane, L-A-N-G, is language. It's doing equals equals. So what you're doing here is you're comparing the value, okay? You're comparing the value, equals equals means comparing the value of the string against that of ES, single quote ES. So it's comparing this string instance versus another string instance to see if their value actually happens to be the same. So in this vast amount of memory spaces, your lane, right, this lane, L-A-N-G, actually sits right here. And this one has a value, whatever gets passed in, and you're comparing against this ES right here. So what is this ES? Well, this ES is a value, right? And what you're doing is you're comparing this value, ES, against whatever is in there, right? In this LANG, there's a value associated with that. Lane, LANG is a memory address because this is a reference. But anyway, that's kind of beyond the scope of Python. You're comparing whatever is in this memory address, which has this value that gets passed in through the argument from the outside, against the actual value that you have locally as ES. If that comparison happens to be good, which means this entire, what do you call this thing? Lane equals, what is this entire thing called from your previous lecture? Lane equals. Remember? What is the name of it? Comparison operator, right? If that equals is comparison operators, what is this entire thing? Lane equals. That, what is that one? Conditional statements, right? Okay, so I'm running out of space here, but anyway, this conditional statement means this statement evaluates, or conditional, I'm sorry, this is not conditional statement. This is a conditional expression. So this is a conditional expression. What is conditional? Conditional means is it true or false, okay? So this expression is going to be true or false, right? This expression is going to have a comparison operator in between, comparing string to string. If yes, then prints all that, right? If lane equals fr, then you print bonjour, right? If this is none other than español or française, by the way, my French and Spanish is very bad. Hopefully I had the right pronunciation. Then you print hello, right? Does it make sense? So it's either this or hello. Okay, so hopefully that illustrates everything we need to in this slides. Next one, return value. Okay, so this is interesting. We so far have not talked about returns. What does that return means? Okay, so this return means return whatever this is, right? This value to the executing body, right? So remember though, what is the executing body? Whoever calls greet, okay? So this greet is now being invoked. Before this print is done, it has to evaluate its greet is. This greet actually returns a hello. So you're gonna see hello Glenn right here. Does it make sense? So this returns whatever the value is, returns a value to be used as a value of the function that call in a calling expression. So this calling expression is really here, okay? Or your executing body. It returns whatever the value is at that moment in time to the guy or the girl, whoever the executing body invokes it, right? To the invoker, okay? So that's what that means. So this greet is going to evaluate something, and the function that invokes it is print. So you're going to get a result first, and then this result will be second, right? So eventually you're going to see hello Sally right there. So that's what return value is. And interestingly, and this is very different from other languages, is in Python, you don't have to specify the return type here. So there is no data type here. Usually, you know, like if you have done Java, JavaScript, C++, you'll see a function declarations out there with a return value, and that return value has a type. But just remember, Python is not strongly typed, it's loosely typed. So you don't have to specify return value. Return value is implicit, right? So if you return 1, right, then this greet is going to return 1. And what's going to be printed is 1 and then Glenn, right? 1 instead and Glenn. But this is not returning 1, this is returning hello. So you're going to have hello Glenn, and the next one is hello Sally. All right, so this is the return keyword. Again, this means that return is a reserved, okay, keyword that cannot be used as your variable names. So I think that's pretty obvious. If you go to the next slide, you'll see another examples where you have this. Okay, there's a question about what is the difference between return and print. Oh, okay, so let's go back. Return is the keyword associated with the function definitions. Return simply means just return whatever this is to the calling body. So if you have a calling body that says greet 0, right? No, let me see this. Okay, greet 0. Like you're writing this, okay? So what this means is that you're invoking this greet, and this greet is gonna return hello. So as soon as this entire expression is evaluated, this greet is evaluated, it will be substituted with whatever it is returning from this function. In this case, hello. So what's gonna happen is this greet at this moment in time. Let's say if this is line 20, okay, line 20. This greet is going to be returned with what's called a return, a value called hello. Okay, so temporarily what's going to happen at line 20, let's say if this is line, not line 20, maybe this is line 7, and this is line A. And at line 20, you have this greet. You're invoking this greet. So at that moment in time, your flow of execution is going to line 7 again, and then line A, and line A says return. So what's going to happen is that entire hello is going to be returned and substituting greet, right? This function call with a string called hello. Make sense? Okay, so how's greet related to print? No, there are two different things. Greet is what we call user-defined function, but print is a built-in function. This built-in function is taking a whole bunch of stuff. In order to concatenate, let's say if you want to concatenate hello world, you can do something like this, okay? Hello, right? And this concatenation actually happens this way, space world. So this allows you to kind of say class CIS, 12, something like that, right? Now this is how you would, using a print function to concatenate various different, this is what we call string tokens. So string 1 is hello, string 2 is world, string 3 is class CIS 12. Okay, so same thing here. You can treat this greet, which returns a hello here, as one of the string. So just like I said, eventually this greet is going to be returned with whatever the value that comes back. In this case, a hello string. So when you do this, your flow of execution is going to go into print, and the print definition is somewhere in memory, right? But that's okay, because your function pointer is going to go right into that memory space and sees this print. There's a whole bunch of logic in there, and one of it is going to involve evaluating what this greet is. So this greet is going to print out hello, and then concatenation through print, you're going to see hello Glenn. Okay, so I think this is a somehow long-winded answer to your question. Your question is, what is the difference between return and print? Print is a built-in function. Return is a function keyword. Okay, there are two different things. Hopefully that answers your questions. Let's move on. Okay, the return value for this one has 3 of them. So I think we went over this already. And function is one that produces a result and a return value. Okay, yeah, so I think the cool thing here is that you can see the color pink. The result is the value, right? You're returning that value. It's what gets printed here, right? It's what gets returned. I'm sorry, it's what gets returned here, right? And whatever gets returned here is going to be replaced. It's going to be replacing this entire green function invocation will be replaced by whatever gets returned. Depends on the conditions there. And then you have this print to concatenate them at runtime. All right. I feel like I'm kind of repeating the same thing here. Do you guys understand what I'm talking about here? And like, any questions about this? Excuse me. Let me also get some water. So my apology here, because I've been talking all day. I had a full day schedule work where I was talking quite a bit today. So if there's no questions, let's move on to the next one, which is arguments, parameters, and results. So we understand what an argument is, right? We also understand what a parameter is, right? And do we understand what a result is? The result is what gets returned, right? So just remember return def, right? So we see a whole bunch of keywords here. The keyword for function is def, right? And the return is usually, whatever happens inside of Vegas, right? Whatever happens in Vegas, that stays in Vegas. This is exactly what happens here. Return W is is what gets computed at the very end of your function. And looks like there's really no computation. There is a hard-coded return W. That is fine. And that max is always going to return W here. Okay? And that W becomes big, and big is not printed, and so you get W here. Okay? And just a review, hello world is an argument that you're passing into the function. And W is what gets returned as a result. And IMP is the parameter that defines what this function looks like. Any questions about this? All right. So I alluded to the ability to pass in multiple parameters and arguments, right? So this is exactly what we're doing here. The ability, right, to pass in multiple arguments. So if you can do that, then your parameter is going to have to be defined and concatenated. Not concatenated, but delimited. Delimited means separating them, right? So now you have to separate the parameters into a list. But the way to do that is to have a comma, basically A comma B. Okay, not period, not exclamation, not pound, right? Not space, but a comma. Okay, so A comma B. So you can have A comma no space B. Is okay. You can have as many spaces you need, but the crux of the arguments here is just to make sure that arguments. Okay, this is kind of that's not what I meant by arguments. It's no pun intended. So what you have here is a function signature that has, and we know this is a function, and we know this is a custom function because I've never seen this as a built-in functions before. So this add to is something somebody added, and it's a function because it has a def in front of it, and this one has the correct signature because it's got this colon separations here, right? And then A and B signifies the parameter. So this A and B are both parameters. And the parameter is doing this, A plus B equals added. So this added is a local variable, okay? And then you're returning the computed results at the very end, which is these addeds. So as soon as you return, what's gonna happen is this added is gonna go out of scope, okay? So nobody's gonna have access to this added anyway. What happens in Vegas ends in Vegas, right? And that's basically the crux of everything that happens inside this function scope stays inside the function scope. And since nobody sees this added, you have to return it. So this add to 3.5 actually returns the added, which is the computed result of A plus B, which is 8 in this case. And that is that expression, right? This add to is an expression that gets evaluated to this number 8. And this equal sign assigns that number 8 to this value of X. So if you print this X, which is a variable that is an integer that has a value of 8, you get 8. Okay, so I just did a translation of what this means from beginning to end. Any questions about this? All right, I'm super glad that we are close. We can see the end of the tunnel. All right. This is void function. Okay, so what does that mean by void function? Void means nothing. Okay, void is not a variable. In fact, it is not an attribute or variable name, or it's not a value, so to speak. You cannot set a variable x, okay, equals void. Okay, there is no such thing in computer science. In fact, in all of the languages that calls for this void, by the way, this is void. Void is a placeholder to signify the return of a function. If a function does not return anything, then that function is a void function, okay? If function does not return a value, we call it a void. Cool. I have never seen this thing being described as this, that a function returns something is what we call fruitful function, and void function is not fruitful. That sounds like every void function is garbage. This is really funny. No, don't think that way, okay? So I don't really like this descriptions at all. But we'll take a look at what those are. Okay, so there is a question. It doesn't return anything. They don't return anything. Okay, sorry guys, I'm just reading out what is in the comments in the chat section. Let me return the sensitive back to what that calls it. Okay, so I think yeah, I think that was just a comment left by, yes, that's exactly right. The gentleman who responded to that one. Okay, cool. Let's take a look at what this void function is. Clear? Okay, to function or not to function, like this sounds like Shakespeare's English major. I'm not an English major. My English kind of sucks. I hate English so much. That's how I got into engineering. Okay, that aside, but English is a good thing. Organize your code into paragraphs, capture a complete thought and name it. Do not repeat yourself. Make it work once and then reuse it. If something gets too long or complex, break it up into logical chunks and put those chunks in functions. Okay, sure. Make a library common stuff that you do over and over, and perhaps, yeah. So I think this is kind of the spirit of why we use function to begin with, right? Because you want to build reusability in your code. If you have your code that is kind of like 200 lines strong, chances are you can kind of compartmentalize your various sections of the code, and there's going to be some duplicities there. So what you want to do is to grab these duplicated chunks of code, put them in a function, and you just keep calling the function every single time you need it. So that will shrink the footprint of your size, right? Your 200 lines of code is going to become maybe like 70 lines, right? That makes your code a lot faster. And the reason that way you will have function is because you want to reuse it, right? Don't repeat yourself, but you want to reuse it so that you can, even if you like, can make a libraries of common stuff. So what does that library mean? Library is simply just a collection of these functions. Sometimes you have like 4 or 5 of these things. Sometimes you have 20 of these things. So library typically signifies a collection of functions that all have some sort of common purposes, right? So this collection of function that is responsible for printing stuff to to a file, or printing stuff all the way to the console, or this collection of libraries that is responsible for communicating, right, your data from client to server, or this collection of data is for drawing something on the screen. So there's different types of libraries that you can do. But essentially, you can think of a library as a collection of functions. So you can kind of modularize your code that way, right? Compartmentalizing it, breaking them down into pieces, like Lego pieces. So certain parts of your pieces could be reused over and over again to build something, right, up. And when I say build something, building your solution up, right? Your solution is a collection of these pieces put together that solves a particular problem. And that is computer science, right? We instruct, right, the machine to solve problem for us. But we also want to make sure that the instructions for telling the computer how to solve a problem is lean enough, right? That the computer can understand it and quickly execute it, instead of going around, going around the world, 20,000 times. I don't know how many miles there is, and then solving the same problem, right? So one of them is pretty idiotic, and the other one is lean and efficient. So this kind of, and because you're the one who writes it, this kind of separates you into either a mediocre developer versus a good developer, or very, very bad developers, right? And nobody wants to hire bad developers. So you all want to be good, excellent developers. Okay, so that is a kind of a quick summary of the reason why we're using function and what we're discussing it. And of course, the summary that summarizes everything from beginning to end. We talked about function. We talked about the signature involving arguments, parameters. We invoke a couple of built-in functions to achieve type conversion, for example, string conversion, for example. We also talked about the difference between params and arguments, and the results using return, right? Return keywords. or the function that does not return anything, like void functions, and why use functions in general. So to elaborate on this result thing, I'm sorry, to elaborate on what this void function is, if you just scroll all the way up to some of the beginning slides that we did earlier, let me see, there's, this is what we call void function, right? This function actually, what you see here, discrete, does not return anything. There's no return here, right? So the effect of this function is leaving some sort of state information on your console, right? It says either hola, bonjour, or hello, right, on your console, but there's nothing to be returned. So this is a void function, okay? Does not return anything. I believe there's also another void function somewhere that we had before, like, so max. Do you guys think this max is a void function or a non-void function? This max is definitely not a void function because max returns something, right? This something is actually that number, that string we're talking about. So this max returns, right? There is actually a return string, right? That returns something. So this is a non-void. That's absolutely correct. Okay, and then I think we can go on and on, but I think we're done with this one. We're doing pretty well. You can rewrite your pay computation. I don't know if this was given. I believe this was given to you as one of the exercises. Okay, sure. If you had that one, this one is not graded, but you can convert this, right? Rewrite your pay with some sort of a function called compute pay, which takes 2 parameters and stuff like that. Okay, so if you go to your homework, you'll see some exercises calling you to build a function with specific function definitions. You have to follow instructions, okay? So if you don't follow instructions, you lose points. If you don't know how you lose your points, you should take a look at your grading rubrics. The rubrics is a delineations of your, you know, how your work is graded. It's going to tell you line 1, if the code isn't run, you lose 50 points, right? So on and so forth. So no, you have to follow these rubrics to ensure that you maximize your grades here. Okay, so that completes what we need to talk about as far as the function goes. Okay. Okay, so speaking of both max and min, right? Let's just do a double check and see that we can at least print something out. If I have ABC here, what do you think the min one is going to be? And if I have print max, what do you think this is going to be in ABC? First of all, max is going to take the biggest one, right? That's probably going to be C. Min is going to be the latest one, smaller one. Okay, so what I have here, let me just comment this out. So I have this one line of code here. And this one line of the code actually is a combination with 2 built-in functions. The first built-in function is called print. The second one is called max, okay? And because I am print, so what's gonna happen is this print, hold on a second, let me see where's my annotations. Okay, so this is your computer space and this is your print. Your print is actually located here, okay? And inside this print, it's invoking this max, which is fine because max is probably here and then you're calling it here. So what's gonna happen is it's inside this print and you have this max, right? This entire built-in function getting passed in as an argument into print. Your print is gonna take that argument in as a parameters, right? And that parameter has to be evaluated. So what's going to happen is this print function is going to be calling max, right, internally. So going from 1, calling it to 2. So this is kind of like this function is calling these other functions. But no, it's not really that. This function is actually trying to interpret what this max is at the same time. And max returns a string. and that string is going to be replacing this max completely, and that string is what we call C. And if you print C, you get C's, right? So you get this C right here. Does it make sense? So that's what this is. We can do the same thing also with printing the minimum, right? So if I go back there and say, I don't want to, I don't want to print this, and notice my results on the right side. So I'm going to uncomment this and just print this, execute, and I should be getting an A here, okay? If I don't want to do that, there's another function called len. Len is the length of this thing. So if you do a quick check here, you can see ABC has 3. So Pasadena City College. So this is the entire string that I wanted to print out the size. This size basically is the length of this entire string. So you can do a quick one to say that, to see that Pasadena City College has actually 21 characters. Does that make sense? So this is kind of another thing that you will see using a built-in functions. Now, I'm not going to go through integer to string comparisons or integer to string to integer comparisons, because you can use what's called in to convert a string to integer. But how would you convert a number into a string? You use what's called stir, okay? So if this is 1, 2, 1, 3, 4, you can actually print this. This will turn it into a string. And because string is printed to the console, and console doesn't really doesn't really let you know that this is a string and integer, you will see 23. So 2, 3, 4 looks like an integer, but it's not really an integer. It's actually a string, okay? Because now you're converted into it. So that's what I wanted to say about that. There's a whole bunch of other built-in functions like randomizers. I'm just kind of going through. This is all in your notes, okay? If you go here, you'll see these built-in functions here, void functions and stuff like that. To the extent the void functions are all part of the chapter 4, right? Chapter 4. So if you go to week number 3, you'll see chapter 4 stuff. So this value returning function is also in your node. You can kind of just look at it yourself, okay? Same thing with your Boolean if else examples that you have there. Let me just go through a couple of them. So I don't think I need to go through all of the built-in functions out there, but what I like to see is the void functions. Okay, so let me just kind of paste it because I don't think I'll have time to kind of type everything in myself. So you have this function. This function is kind of long, and this function is printing out a whole bunch of. First of all, you can, if you really want, you can concatenate these things. Oh, actually, I don't think it's going to work well. Let me see if this compiles first. This compile means that this at least runs, right? Okay, so you have this function definition, and this function definition is printing out. It's taking 3 parameters, right, in there, and what it's doing is it's trying to convert first name into a string, which is fine because first name can come in as an integer for all I know. Last name too, and then it's trying to convert age. So it's basically converting everything into string and trying to concatenate everything, right, using a plus sign. This is totally fine, and then and print it to the screen. So there's the print right here. So that's what essentially what this thing is doing. So if you were to invoke it, because by the time that you get to line 5, line 1, 2, 3 would have been actually line 1 or 2, because this is run on. Let me see if I can make this smaller. Yep, so that way you can see the entire thing. Okay, so line 1 or 2 would have been loaded in memory. So what you need to do in line 4 is to invoke it, right? Since line 4 is evaluated after the loading of the above into a memory, you can write something like Joseph Su. Technically, you don't really need to convert this first and last name plus the age. Actually, age needs to be converted, but Joseph's first name and last name is already strings. So converting a string into a string is kind of redundant. It actually slows down your code because you have to convert it manually. So let's say I'm 18 years old, which I'm actually 17. No, I can't. I can't be 17 be teaching this class. And you can see Joseph Su is 18, right? So technically, if you just remove this str here, because last name, first name is already a string by itself, you don't necessarily need that. You should still be able to execute it. Okay, so you see Joseph Su 18. So this runs, right? What do you think about removing this strh, right? Would it run? It might be possible, and this possible is because there is a implicit convergence here. The h itself gets turned into a number. That is actually not the case. What's actually happening is your print is capable of taking into some arguments in there, and because you're doing concatenations, it's not your print. Your concatenation. This is string concatenation. String concatenation is basically setting aside the string. We'll talk about string, right? This is actually a very big chapter. The string is taking these tokens, and before it can convert these tokens into a string, no, actually before it, this concatenation, which is a process in converting, in appending all of the tokens into this giant string, is checking to see if each token needs to be, token means a substring, needs to be, is of the same type as the rest of it. And because this thing we know is a string, and this last name is a string, so everything is good up until this point, and you have the plus sign equals a number, and that concatenation, the implicit conversion actually happens during string concatenations. So it has nothing to do with print, but because this is all done internally when you create this brand new string buffer that consists of everything, and that conversion happens there you're able to print everything out without converting anything, okay? So this is one example of a, what we call, this is non-void function that takes 3 parameters, okay? Arguments, 3 arguments in this example. Okay, make sense? And this is how you execute, right? Execute or invoke. Sometimes we call them execution. Execution is not a pretty word, but sometimes you call the function or invoke a function or execute this function. This is how this program gets executed. Okay. Execution also means evaluations in the context of computer science. Okay. Do you guys have any questions about this at all? Again, I mean, we can go on for more of these. Let me just double check, make sure that we cover everything, okay? Yeah, let's just get rid of this. We can have a function that does nothing other than printing out be fantastic. So what would happen if we just call it? What do you think? It returns a string. But this string is not getting printed, so if you execute it, you can see nothing gets printed, right? Why? Why is that? Well, because you're not printing it, right? So if we were to print this would have been, so print means going printing it to the console, so you see be fantastics, okay? Does it make sense? So what does the return do? Returns the payload, whatever this is, back into the caller. So in this case, this entire return message would be replaced by this be fantastic. And be fantastic is itself a string. And if you print that string, you'll see it on the results. What would happen if you have this? Well, first of all, this is possible. You can actually just keep adding whatever, right? This is possible, but there's a problem. As soon as the return is called, the very first return is called, this returns to the caller, okay? So your line number 3 and line number 4 is never even gonna be evaluated. Like your flow goes in there, sees the return and returns, done. So this is not gonna be evaluated. So this is not gonna be evaluated. So this is kind of, so line 3 and 4 are junk, basically junk, okay? Let's run it and see what happened. Okay, as you can see, it's printing fantastic. I'm sorry, let me just get rid of this. I'm gonna say be fantastic with a whole bunch of exclamations so you can see the differences there. So I'm gonna execute it. Okay, so as you can see, this thing gets printed, but line 3 and 4 are basically junks. So this is bad code, but it's not a wrong code. It's just bad. Why would you want to put some junks in it to begin with? Okay, I guess I can kind of elaborate on these things, but you can make this pretty complicated. Having something even like this. So this is an example number 7. The fact that you can define multiple functions. So how many functions do we have here? We actually have 4, okay? So this is the function number 1, function number 2. These are all custom functions that user defined. So you can collect all of the integers through these 2 lines of code, which we know what happens, right? The user enters something, and because there is no except and tries here, you gotta be super careful, right? What you can do is you can collect your integers that way, and guess what? This is how you do it. So let's take a look at this and see what happens. Collect integer is a function, right? So that function is actually right here, number 1. It goes in there and collects A and B, and then what you can do is you can return a whole bunch of them at the same time, concatenate it using delimit it using a colon. So the good news about this is in Python, you can get multiple stuff back, right? Not just A, not just B, but A and B together. And the way that you do it is using a comma. So you're using a comma here. So what's going to happen is A is going to be, so this num1 is A, okay? Num2 is B. Okay, so you get A and B back. And this is under the assumption that whatever you enter is a numeric string, right? Numeric string that gets converted using this in there. Now, notice that this is very dangerous because there's no try except here. So you have to basically at the user's mercy that hopefully they enter something that is numeric string. If not, then this code is going to exit with a trace back, which is trace error, which is pretty bad. All right. The upshot is you get num1, num2, assuming they're valid, and then you do the addition. So this addition adds both of them and returns the computed results, summations back, which is the return sum. And then you take the return sum into this checking sum to say if the sum is greater than 0 or equal to 0, returns true or false. So this thing is going to be a true or false. It basically shows whether your sum is greater than 0 or not. That's the end result, right? And then what do you do with the end result? You can print the rest of it. So I'm just copying verbatim from your example number 7, and then you can see what gets kind of printed. I know this is kind of occupies the entire screen. And you can see that I'm printing this value one at a time to the screen, and then return false to true, true or false is basically there. So I'm not going to run this because on someone else's machine, I don't have the console input. I have to do something here, which I'm not going to do. But again, this is number 7 example.